Hello, welcome back. We're going to look at composition again in this video. So some of this will be a review, and then we're going to look at one very specific issue, the issue of the this keyword and how that relates to what is static and what is dynamic in your Java classes. So let's start off by talking about composition. And some review here. A class is a data type. And people call these abstract data types or user-defined data types. And an object is an instance of a class. And I want us to recall the has-a relationship. When you define a class, the name of the class will be a noun, and that noun will have properties. So if we say a contact has a name, a contact has a address. If you say it out loud in English and it makes sense, then you have the right object-oriented design. It's intended to be easy. That's why it works. Composition, the concept of composition, is the has-a relationship. So a X is composed of a Y and a Z and something else, as many of those as you want. So a contact has a name and an email address and address and a telephone number. So this is the concept of composition and the has-a relationship. So I've made a partial class here. It's not complete on this slide, and we're talking about a contact. So we're saying we're going to make a contact manager to keep track of the information about the people that we know, maybe our customers, maybe our friends, whatever. And we say a contact has a name and a contact has an address and some other things, but I haven't included everything here. So look at the data types that we're using. For the contact's name, we're using the data type string, and for the contact's address, we're using the data type address. So we're composing a contact class from objects of other classes that we've also created. So for some reason students find this difficult. If you're looking at this for the first time, you're very comfortable typically saying that the data type for the contact's name should be a string, and then somewhat less comfortable saying that the data type for the contact's address should be address. Both of these are the names of classes. This is one that we created, and this is one that we didn't create. It came with the JDK. So you should start to not worry about the difference between whether it's a class that you created or a class that came with the JDK or someone else has created. So look at the constructor method for the contact class. What does it take to make a contact? It takes a string object and an address object. So you can think of when you call a constructor, when you say new contact, you have to give it what it wants, and what this contact constructor wants is a string object and an address object. And look at the mutators, the setter methods. Set the name of the object that you're creating, or set the name of the object that you're manipulating to this new string object, and compare that to set the address of this contact to this new address object. So those are exactly the same thing, except this is a class you created and this is one that you didn't create. The return type of the getter is it returns an address object. The return type of the name is wrong. Oh, good. A visual aid. So this is a bug. It won't compile. GetName must return a string object, not a primitive. It's defined here. Oh, and I've got month here. I did cut and paste from a previous example where I was returning an instance variable that was a primitive, and now I've messed this one up. but I think you can probably still do this, and I won't have to go back and fix this and repeat it. You return the data type of the instance variable, and the instance variable of name is string, so the return data type here should be string, and the variable we're returning should be the name. And the dogs say hello. Okay. Now I want us to look at the keyword static, and you've seen this before. The main method, which we've been using since the very beginning, is a static method. And in one of the previous segments where we talked about creating methods and passing parameters to methods, we used static methods as the example. So now that we know how to make classes and we have methods inside of our classes, we have to have this conversation about what is a static method versus a dynamic method. So let's start out by talking about instance variables. So this class contact has some instance variables, and that means that every time you make a contact, you get an instance of these variables. So each contact has a different name, and each contact has a different address. So that should be fairly simple. And when you make a new contact object, these pieces of data are allocated dynamically. So at runtime, when you say new contact, calling the constructor method, you have a piece of memory allocated for that object that has enough room for a string object and an address object and whatever other instance variables there are in that class. So let's contrast that to a class variable. A class variable is not an instance variable. There's only one copy. No matter how many instances of the class you make, you get only one copy of the class variables. And the class variables will belong to the class. Instance variables belong to the objects. So each contact has a name. That kind of implies that the name belongs to that object. But we might want to have a shared variable among all of the instances of the class. This will get clearer as we go along. Don't panic yet. We can also have instance methods that belong to the object. So when we looked at the date class, we put methods in the class like getMonth. So an instance method only makes sense when it's called from an object, and it only can be called from an object. So we said birthday, which is a date object, call its getMonth method, and you would be retrieving the month variable from that object. So this getMonth method is an instance method. It belongs to the instance of the class. Static methods belong to the class, and they're called from the name of the class, not from the name of an object. So here's an example of calling a static method. There's a class called math, and it has a bunch of static methods in it that are called from the name of the class. So we would say math.square root of 100, and it would return a double that we could put in a double variable. So how do you know, when you look at a method call, how do you know that this is a static method call and this is an instance method call or a dynamic method call? Well, hopefully your class names have all started with a capital letter, and now we can read the code and understand which ones are static and which ones are dynamic based on this is the name of a class, but this is the name of an object. Okay. So what we're going to do now is we're going to start another example from the beginning, another object-oriented design example, and we will incorporate things that would be usefully added to that example that would be static and some things that would be dynamic. So when you're doing an object-oriented design, you have a problem that you want solved, and a group of all of the people interested in the project sit around and talk about the project. And when you say the name of a noun over and over, that will probably be the name of a class when you go to implement the project. So let's talk about the project that we're going to start building, and it's going to be a racing car game. A racing game with cars. And these cars are going to be objects in the game, and we will have these cars at some position in the race as the race progresses, and each of the cars will be going a different speed, and it will be very exciting. So this is kind of a very, very small example, but I need it to be small so that I can make the points that I need to make without it being too cluttered. So let's go immediately to Eclipse and look at the beginning of our race car game that we're going to develop, and we'll start building the first class for that game. So here's some code that I've written, and you can pause here and look at this code for a minute if you want to, or I'll just go through it and explain to you what's going on. So we talked about an application that we're going to write. It's going to be a racing game, and one of the things that we kept mentioning in the conversation was that there would be cars in this game, this racing game. So I made a class called Race Car, and a race car has a speed and a name. It could have lots of other things, but I want this to be a very small example. And so we could make lots of instances of this class, one for each car in our race, and each of the cars could be going at a different speed, and each of the cars would have a different name. So the constructor method, it takes the speed and the name, and I'm going to skip this one for now. I'm going to skip this one for now, and here is the accessor for the speed variable, get speed, and here's the mutator for the speed variable. The rest of this class is what you would expect: get name, set name, and toString. So we're following the conventions for making a class in Java with constructors, accessors, and mutators. So now the new part of this. I declared a variable here called max speed for all. So because I'm afraid that they might have accidents if they go too fast, I've decided that I'm going to declare a variable that will be the maximum speed that they're allowed to be going. Maybe if there's a warning flag, I could reduce that maximum speed. Everyone has to go less than 40 miles an hour or something like that. But if we make 100 cars, well, let's make it realistic. How many cars are in a race? I don't know. 20. If we make 20 car objects, we don't need 20 copies of this variable because it's shared for all of the cars. So we're going to make that a static variable. That means it belongs to the race car class. It doesn't belong to the object called Andretti or the object called, I can't even remember the names of any other race car drivers, but you know what I mean. If we make 20 race car objects, there will be 20 different speed variables, and there will be 20 different name variables, one belonging to each of the objects, but there will be only one of these. Because it's static, it belongs to the class, not to the objects. Okay, so I've said that about 40 times now. Don't confuse the static keyword with the access modifiers private and public. You could have a private static or a public static, a private dynamic or a public dynamic. Those are different concepts. Okay, now we have a static method. Whoops, what did I just do? Oh, I closed that one up. Okay, we have a static method here. This static method allows us to change the max speed for all. So this shared variable, the static variable, can be changed and it can be retrieved, both through static methods. And those methods are going to be called not from the name of an object, but from the name of a class. So as we're writing the algorithm that will run the race, we can change the behavior of the race by adjusting this variable, this static variable, and then we would change what the cars could do, all of them at once. So look at the mutator for the speed variable. When you go to change the speed of a car, we check to see if the speed you're trying to change it to is greater than the maximum, is less than or equal to the maximum speed. So we don't want to allow the car's speed to be changed to something that's greater than the maximum speed. So we're inside of a dynamic method here. This can be called only from the name of a particular car object. But we're checking inside something that belongs not to the object, but belongs to all of the cars equally, the static variable. So let's go and have a look at how we can use these static methods and static variables in our main method. So I have a main method here, and the first thing that I do before there is any car objects created, race car objects, I'm going to call this getMaxSpeedForAll method and store it in this local variable. So here's what I want you to notice, that the static method is called from the name of the class, not from the name of an object. In fact, we're calling this method before we even have any objects of this type. So the statics do not depend on things that are in the object. Now we're going to make an instance of the car. So we made a car that's going 60 miles per hour, that's its speed, and its name is Andretti, and then we're going to change the speed of the car to 100. So this is a dynamic method. It belongs to the object called Andretti, and we're changing the speed or the instance variable speed of that particular object. And when we're calling the static methods, we're not basing what we do on the name of an object, we're basing it on the name of the class. So a class variable or a class method is static, and an instance variable or an instance method is dynamic. Now this one is I'm throwing this in to show you that you can do this and you're not supposed to. So this is a static method. Eclipse puts static methods in italics for you. And you can, in Java, access a static method from the name of an object. And there's a warning message that pops up and says the static method from the type racecar should be accessed in a static way. And the quick fix is to change the access to using racecar. So this will compile, and you're advised not to ever do it. Don't call the statics from the name of an object. It misleads you into thinking that something is happening with this object, but it isn't. So I need to make one more point here that will help you understand what's going on. The point is, when does data come into existence? When does it get allocated in memory for your use? So let's go back to the race car class and look at the data that will get allocated. There are three variables: speed, name, and then this static variable max speed for all. These get allocated only when you create an instance of the class, and they get allocated again each time you make an instance of the class because they're instance variables. Things that are static get allocated the very first time you mention the name of the class in your code. So at runtime, let's go back here. At runtime, we mention the name of the class race car. The Java virtual machine then goes out and grabs the racecar.class file and loads it into memory, allocating the space for the static variables. Only then, at runtime, when the name of the class is mentioned. So on this line of code, the max speed for all static variable is allocated and available for you to use. You might notice that on this line of code, there are no name or speed variables because we haven't made an instance of the class yet. So on this line of code, when we create a race car object, what Java does is it runs out and it allocates the space for the speed and the name of that object. And then we can start manipulating it. Why is that important when things come into existence? Let's go and look inside the race car class again. So we've got a static method here and a static method here. Suppose for whatever reason, when someone calls set max speed for all, we want to change the speed variable. Let's try speed gets 40. And this won't compile. The speed variable cannot be accessed inside of a static method. Why? It hasn't been created yet, and it belongs to an object. So this doesn't compile. Let's go back and make sure we understand that. We're calling the set max speed for all method, or the get max speed for all method, it doesn't matter which, a static method before we have even created any race car objects. It isn't possible that we could manipulate the speed variable because the speed variable has not been allocated yet. So a static method does not depend on there being instances of this class. And therefore, inside of a static method, you cannot mention the name of an instance variable. The statics are always available because the first time you mention the name of a class, Java runs out and gets the class and allocates the space for the statics. So if the static methods are available, but the instance variables are not allocated, then it wouldn't make sense to be able to mention the instance variables inside of the static methods. Let's contrast that with this method. The setSpeed method is a dynamic method, but we can mention the name of the statics inside of the set of the dynamic methods. So the statics are always available. Let's look at the call to the setSpeed method. So we're taking this race car object, and we're calling it setSpeed method. How do you know that the dynamics are available? Well, we have an object that was dynamically allocated here, so we know that the dynamics are available. And how do we know that the statics are available? Well, the statics are available all the time, as soon as you mention the name of the class the first time. It would be impossible to make an instance of this class without mentioning the name of it. So we know for sure that if you have an object of a particular type, that you also have the statics available. That means that this dynamic method or instance method setSpeed does have the static variables available. And when we try to change the speed of the car, we can check to see if it's within the bounds for all of the cars. So far, so good. Okay, what we need to talk about now is the keyword this. And I slipped it into this example without telling you what was going on. But on this line of code here, I've used the keyword this, and I've said this speed gets speed. Okay, the parameter name here, or the local variable, which is the value that was passed in, I named it speed because that's the appropriate name for that local variable. But now that creates a problem because we have a variable called speed here, which has class scope. And we have a variable called speed here, which has local scope. How will Java know which one we're talking about? If you just write speed gets speed, that doesn't do anything. A variable always has in it what it has in it, so assigning it to itself doesn't change anything. So what we want to do is to take this variable, the one that belongs to the object, and assign it the value that was passed in. This is the only time in the entire language that that happens, by the way. We have two variables by the same name in the same scope. And the only way it can happen is if one of them belongs to the object and one of them is a local variable. So what you're advised to do, what beginners will do is change the name of this to something that's spelled incorrectly so that it won't conflict with the name of the object that the name of the variable that belongs to the object. Sorry, but that's not what you're supposed to do. Call the variable what it is, and then distinguish between them by using the keyword this. Okay, what is this? This refers to the object that got you into this method. Okay, so let's go back to where we call the setSpeed method. And we said Andretti setSpeed. So it's a dynamic method. It belongs to an instance of a car. So whose speed are we changing? We're changing Andretti's speed. So when we get inside of the setSpeed method, this refers to the object that was known outside as Andretti. Okay, here's what I want us to do. I want us to walk through the setSpeed method in the debugger. So I'm going to set a breakpoint there, and I'm going to click on the little bug, and it says it will change the perspective. That's okay. And now we're pointing at the setSpeed method. That's what we're going to execute next. So let's look at the Andretti object. In the main method, we have these variables available. The Andretti object is a race car, and it has the name and the speed. And now we're using that object to step into the setSpeed method. So I'm going to step into the setSpeed method, and what do we have available now inside of the setSpeed method? Well, we have a variable called this. This is the object that got us into the method. And if we pop that open, we can see, yes, indeed, the object that got us into this dynamic method has the name Andretti and the speed 60. So if we start to execute this, we will execute the statement this speed, which is that excuse me, that variable right there, gets speed, which is the 100 that was passed into this method. So the little L here means that it's a local variable, and the this is the object that got us into this dynamic method. So when we say this dot speed, we're talking about this variable, and when we just say speed, we're talking about this variable. Maybe I should say that variable. So when I step over and step out of this dynamic method, now we're back in the main method, which is static. Look over here. There is no variable called this. Anytime you're in a static method, there is no this. There is no object that got you into the static method. Let's prove that by stepping into the getMaxSpeed4All. That's a static method. It's erroneously being called from the name of an object, but that's okay. Let's step into it, and what we notice is there is no this. There was no object that got us into this static method. Objects are not used to call static methods. Classes are used to call static methods. I'm just going to hit resume and let that finish, and then switch back to the Java context so that we can see more lines of code. Well, I hope I haven't beaten this up too much for you. I don't know at this point whether this is a really difficult concept for you or a really simple concept. But what we're going to do is we're going to use this race car object, this race car class, and we're going to make a race. And let's declare that this race has some length, and we'll say that the length is 1,000. I don't know what it should be. And now we're going to say that each car must have a position in the race, the position that they're at between 0 and 1,000. So now we're saying that not only does this race car have a speed and a name, it has a position. Maybe I should call that location. The location in the race, as opposed to the position. You might think it's in first place or second place or so on, but the location in the race is where it is, and it can start at 0. So every car, when we create it, starts at location 0 in the race. And it needs an accessor and a mutator. So let me show you something that's really fun. I'm going to right-click in the code window and say Source, Generate Getters and Setters. And I'm going to choose the location variable and say OK. So look what it did for us. It generated these two methods for us, getLocation and set location. You might also notice that it correctly used the keyword this. So the name of the parameter to change the location of the car, the name of the parameter really should be location because that's what you're changing. And then we're distinguishing between the instance variable and the local variable by using the keyword this. So I didn't show you how to generate the getters and setters in Eclipse before because I want you to type them a few times and then understand that this is so routine that Eclipse can just type it for you. So let's go back and think more about our game, our race car game. We're going to make a bunch of race car objects, and then we're going to continue while no one has won. Well, this loop would continue while Andretti hasn't won, because Andretti's location is less than the length of the race. I'm not happy with that variable. I wish I had called this race length instead of length, because length is used for so many different things. Okay, so while you're typing and you decide, oh, I'm not pleased with what I've done, especially if you've used it in like 20 pages of code and then you decide to change the name of the variable, that can be a real pain. So what I'm going to do is I'm going to highlight this variable and I'm going to right click on it and I'm going to say refactor and then rename. It says enter the new name, so I want to call this race length. And then press enter to refactor and it will go through all of your code and change that variable to the new name which you like better. Isn't that fun? Refactoring in Java means that you make some small change to improve your code and you make that throughout the entire project. Okay, so you might start to see that we have the beginnings of a game which is implemented in the main method. It's not a very fun game, but we might then start to write code that checks of all the cars that we have in the race, who's in first place, and we might do some output that says, oh, calling the race, it's not going to be a really exciting computer game, but our purpose, remember, is to get used to making objects that do something and that have data and methods, and then we can use those objects and kind of get comfortable with object-oriented design and object-oriented programming. I really want to comment this one out before you all write it down and just put a note here that says it should be using the name of the class. Okay, very good. Let's just do a quick summary of what we've looked at in this video. Okay, to summarize what we've looked at, we talked about class variables and class methods. And these are data and methods that belong to the class, and they have the keyword static used to modify them. And we contrasted that with instance variables and methods which belong to the objects. There is no keyword dynamic in Java. If something isn't static, it's dynamic. So static methods, they belong to the class and they really should be called all the time from the name of the class. So here's an example of a static method call. You can tell that's the name of the class because of the capital letter. And here's the example of a dynamic method call or an instance method call. And it only makes sense when it's called from the name of an object. So if we wanted to get the month out of a date object, we would have to have a date object to get the month out of. It's really just that simple. The keyword this is a reference variable, and it's a reference to the object that was used to call the method that you're in. So the keyword this exists only in dynamic methods because it's the dynamic method that you call using an object. So inside the getMonth method, this would be referring to the same object that was used to get you in there. Static methods can only call other static methods, and they can only refer to static data. Because static methods don't depend on instances of the class, you can't refer to things that don't yet exist. Static methods are always available, even if there are no objects created. Dynamic methods can call not only other dynamic methods, but they can also call the static methods, and they can refer to the static data. And the thing that I didn't put on this summary is that I don't want you to confuse the static designator or modifier with the access modifiers, public and private. So you can have a public static, a public dynamic, a private static, a private, you know what I mean, all combinations. Okay, this is big progress for us, and it's time to go and work on some exercises that use the concepts that we've learned, including the static data and methods, and also to get more comfortable with just creating objects of our own design and making them do something in an application. I'll see you in the next video.